Hello everybody, welcome to session 6 of the Unity Study Jam. In this session, we'll be looking at intermediate C# scripting and how to use that in your game. So for this session, we'll be doing something a little different. Since the goal is to actually understand how scripting works, let's not do everything live, like sit and code like in this video. Rather, I'll just show you basically how scripting works with an already built example. This is just an example of a game that has already been built. So let's try to understand how that script actually becomes into the game that you play. This way it'll be easier for you to actually visualize how code becomes into output, and we'll for sure give all the scripts that we have used to you. The link is basically there in the description, you can take it from there. So we'll give all the scripts to you, and you can also use it based on what you need for your game as well. With that being said, the format for this video and the next video will be very similar, where we'll have an already built project and we'll try to reverse back from that. So this is not the exact game that we're doing in the time lapse. The aim is going to be the same, building the endless runner game. This is a slightly visually different version than that, that's all. And the time lapse videos are still going to be there at the end of each session. So let's get some things straight before we actually jump into the scripting portion. First is basically understanding what an empty object is. So head over to your hierarchy and click on create empty, and then you'll get this particular game object here. How it actually works, I'll take this for an example. So we have this particular terrain over here, but then as you can see, it's not just terrains, but you have a lot of other characters inside it, which is like the cheese and then the house, all those kind of things. So what we're trying to do is group them all together so that it's easier for us to understand which belongs where. So all these particular cheese objects, and then both the terrains. So here I've used 2 terrains to build the game, so you could do that as well. And then the house and everything, all of them belong in the same collection. So that's why we have put them all under, like, it's like putting all of them under one house or one roof, which is basically a game object. So let's say I want this cheese, right? I want cheese inside this game object. So I'm going to duplicate it. I'll basically just, this was the duplicated one, I'll just drag it out and put it inside the new one that we created, which is basically game object. So as you can see, this is the cheese over here inside the game object. Like you, if you can remember from where we learnt about lighting and camera, we spoke about parenting the camera. This is very similar. So you're putting them under the same group. So that's what cheese, this is like what we have done with the cheese. So let me just remove it. So this is just so that you understand the reference to this, so that it's easier to understand what's going on in the script. All similar objects have been grouped together under one particular collection. And then why do we have so many terrains? As I had mentioned in the last video, at the end at least, I had only shown how to build one particular environment or one particular terrain over there, and then I had asked you to build multiple more. So for an endless runner game, right, this is the concept. You want the game to be going on forever. So what you would do is create 4-5, you can call these maps as well, create 4-5 maps and then randomly generate them at each and every point, so that it gives you an illusion of your character running forever and that the game never ends. That is the crux of how an endless runner game works. So that's the same thing we're doing here. These are like around, there are like 4 to 5 maps that we have built over here, and all of these will be randomly generated throughout the game, and hence the character can keep moving on forever. The more number of maps you have, the more random your game looks. So this is the second concept. Third one is just understanding a bit more about animation. So before that, I'll just play the game and maybe show you how it works. So what this character can do is, like, if I press the up arrow it jumps, if I press the down arrow it slides, it can collect all the coins, and then once it crashes into something, the game ends. So this is just a very simple rough demonstration. So as you can see, my character is doing 3 different operations. It's basically running, jumping, and also sliding basically. So these are being controlled by your animator controller, which we have learnt about in our previous session. But over there we didn't look too much into what this graph over here does or what the state graph does. Today we'll be looking into that also a bit more. So how does it actually work? When the game starts, I wanted to start running. That's the animation I wanted to perform. So for this one, I've taken an animation where the character runs in place, and then I've just adjusted the script to make it look like it's running forward. So that's the running state. The sliding state is what you saw when you press the down arrow, it slides, and the up arrow, it jumps. And why have I built this particular state, this graph this way? So after the game starts, move to running. And then through the script, I am basically calling this particular animation when the up arrow is pressed. So the point with graph or this transition graph or the state graph is basically that whenever an action is performed, you need to also give a complete path for how it ends. If you don't, it will just stop abruptly. So for example, after jumping is done, I need to give it space to go back to running. If that does not happen, my character will jump and then it will just not do the running animation at all. Same way for sliding. I want it to get back to running. That's why I'm giving it a path over here. You might be wondering why I'm not going from running to jumping. It's because I've used a script to call that. And then as you can see, there's actually a triangle over here. How do you get the triangle is when you add a transition to loop to itself. So when I do this basically, or let me just remove this. And I make a transition, and when you do this, you can actually see the triangle arrow, which means loop it to itself. So why we do this is because let's assume you're not clicking on either one of these, you still want your character to run. And since the animation that we got was just like running in place, it will run for the duration for which the clip is meant for, and then it will just be static. So I want this to keep going on and on forever, and that's why we have the self loop over here. So this is the intuition behind the state graph. One more thing I've done is adding something called a parameter, which I've added it for running basically. You can add it for the other things as well, but here I've just added it for running, just to give you all the different possibilities you have. So what you do for a parameter is click on the plus sign, and you can choose what kind of a variable you want, what data type you want. I have basically used integer over here, and I have named it action. So what I have done in the script is that whenever the value is 0, I want it to keep running. So that's why I've used the parameter over here. So quickly, if you want, I can do this, give it some other name, and I can reference this name in my script again. So that's how you add a parameter. So you can basically click on any state and add a parameter, or you can like change what value each state has to have. So if I give 1 here, it will basically change everything to 1. So you have to basically control that through the script. But then I've kept it simple here. Keep a action, I've called it 0, and then in the script what I've done is anytime the action is at 0, I want it to basically keep running. That's the idea there. So with these 3 things out of the way, we can actually dive right into the script, and we'll look at other concepts as they come along. So I have used around like 5-6 scripts for the particular game. In this session, we'll mainly be dealing with ones that are not based on UI and just based on all the functionalities we have seen. And since the first one that we have dealt with is running, let's just head over to the running script. So this is how the script for the running actually looks. As I had mentioned, I've used the action parameter as 0 for when I wanted to keep running. So what is anim here? So I have used anim is basically the variable I have used to basically control the animator, and you might be knowing by now how to add the animator, like attach the game object to the script or the script to the game object. Basically when I come over here, I have the script, and as you can see, 2 variables I have used, and since they are public, they are available over here. So for this one, I have referenced the animator controller, and for this one, I have referenced the mouse. So I have just declared it over here, and then when integer is at I'm just setting the value to 0. Whenever the value is 0, the character keeps running. That's the goal. So when it starts, I want it to run. Then I want it to, in every single frame, it has to keep moving forward. We have dealt with all of this in the previous session, so just a quick run through. Want this to keep moving forward, and then I also wanted to have the same running animation that happens along with it. That's why we have both of these lines together in update, and then a bunch of if statements for all the actions that it has to perform. The left arrow moves it in the left side, right arrow moves it in the right side. This is pretty straightforward from what we have done. And then we have the other two here, which is more important, which is the up arrow and the down arrow. When I click on the up arrow, I'll directly just do just a single line, which is called anim.play, and then I'll give the name of the particular animation I wanted to do. As you can remember, the animation that we had used over there was called jumping. I'll just quickly go over there. It is jumping, so I'll give the same name over here. Similarly, the other one was running slide, so I've used the same name here as well. So that's the purpose of using both of these. When I give anim.play, it will just call that particular animation that will start playing, and then you have to make sure that in the transition or the state graph, you give a path back to the running animation so that it has a place to go back to. So that you need to do. So it's a matter of joining both your animator, or rather setting up both your animator and your script to work well with each other. And then you also have this other line over here, which is for moving it. So the goal of this is basically, whenever my character is sliding, it also has to keep moving forward and not like just slide statically. That's the reason for having this. If you can't like look at all the code right now, we'll for sure, as I mentioned earlier, it's there in the description, so you can just look at that, all the scripts. So that is how running works. I hope you understood the way all the characters run. That was the first script we wanted to see, and the next one would be let's see. Okay, the other ones are fairly smaller. This is the major script that we have to understand for intermediate C#. Like this controls how your entire game works. Before we actually come to the next script, right, there's a small concept that we need to deal with, and that is called a collider. And so for giving you an example of what a collider does, now let's say you go like hit your friend or something. It's a bad thing to do, but then let's say you hit somebody. What happens is, the moment you hit them, that's when they realize, and then they come up with a response to it. The collider works in a very similar fashion. It basically looks for something to actually or for two things to actually hit each other, or that's kind of keeps track of what is actually touching it or what is triggering it. So let me show you an instance for a collider. So let's say this particular stone is there. So obviously I don't want my character to go run into the stone and it'll probably like fall down. So I don't want that to happen. So what I'm going to do is add something called a collider. So as you can see, how you would do that is click on add component and then click on collider, and then as you can see, there's a lot of types. You can choose one depending on what object you're actually using. Mostly a box collider, people use box or a mesh collider. Box is when you have like a cubical space around it, and then a mesh basically just wraps itself around your object. Depending on your use case, you can choose one. In this case, I've used a box collider, which is basically wrapping itself around here. So what I'm going to this is what I'll be controlling with the script actually. So once that's added, I'll check is trigger basically. So why I need to check is trigger is because that is what will keep checking if something's actually hitting the collider. If it's hitting, obviously a trigger is happening, and that is what I will use in the script as a reference. How you can adjust the collider. So basically anything that is within the space of this box will trigger the collider. This is the essence of how the collider works, and I've used it for every game object here. But then what each functionality should do that is something you'll control in the script. Again, that's the use of the script here. So when I hit on the cheese, right, my character shouldn't die. Rather, it should be able to eat the cheese and just move on. But if I click on the stone, then my game ends. That's the difference that you have to do in your scripting. But then, as you can see, all the colliders that I've used have a similar property. The only thing you might need to change for your particular game would be these parameters, which is basically the size and then where you want it to be centered. You can try playing around with these values to actually explore it more. It's more fun when you explore it and see what happens. So this is the basics of the collider, and I've also added a script over here. So what I've done, every time I have an obstacle, I've used an obstacle script over here, and I've used one for the cheese. So let's just look at both of these now. So that's where I'll be using this obstacle. So when you're using collider, so before we knew a start function and the update function, for a collider, this is also an inbuilt function. So like you can't change the name of this. If you want to invoke a particular action, when you hit that collider, you need to use this on trigger enter. So when you touch that particular collider, I want this thing to happen. So for the obstacle, basically I'll disable the collider. I'm just doing that because once I've entered it, obviously the game is going to end. So I'm just disabling that collider, and then the character also stops running. So everything, so all of these becomes false, or rather I'm even disabling the character itself, because I shouldn't allow anybody to do anything with the character once the game ends. And this is something we'll see later. So I have actually created different scenes. This we'll probably deal in the next session also about what it is. So I have around 2-3 scenes over here. End scene, you had seen the screen where it said game over or something. That is what is there in end screen, which is designed with the help of UI. So what this line does is, once the game ends, load the end screen for me. The game stops there. So that is how this works. So anytime you've used a collider, there are a few functions related to it, but for our purposes we'll be using on trigger enter mostly. The other ones you can look at in the documentation. That's the first one we saw, and the second one was collect cheese. Again, I have a collider here, and on trigger so on trigger enter, I'll basically have to do a particular function here. So you can see this particular line, right? So how does this work? I have another script over here which is called count cheese. So there I have declared a variable called cheese count, which keeps a track of how many cheese I've collected so far. So that's the purpose of that script, and also to display that in the UI. Again, we'll come back to this in the next session also, where we'll be looking at UI. So this line is for that, and then cheese count is to keep track of the amount of cheese. So what I've done here is refer to that particular script and that particular variable, and every time I touch the collider, my value will become +1, and then I'll set that as false. Or what happens is, as you could have seen, once the character hit the cheese disappears. So that is what this thing does. So this .game object .set active becomes false. Why this? Wherever you're using the script, so I have used this script on the cheese itself. So obviously this will refer to cheese. That's the meaning of this .game object. Since the script is attached to the cheese game object, this refers to cheese, right? So if you have understood both of this, you can kind of get an idea of what your script is actually doing. So I've used this to reference to a script where I have a value called cheese count, and I keep incrementing that by 1 every single time my character hits it. So I have a parameter here called collider other as well. So I'll just quickly show you what's happening here. So I have cheese over here, but then what we have done here is, instead of particularly saying that my character, it's like only when my character is like hitting into the cheese I want to stop. We have not done that, since we have only used a character here. So first thing is that your character also has a collider. right? And that should not have this trigger, because when, let's say, your collider touches the cheese, then if is trigger is tricked over here, then that will also cause an action in the character. But I don't want anything to happen to the character. I just want to change what the cheese does or what happens to the game. So I've put a collider for my character and I've removed this trigger. So that's how it basically understands. Why I've given collider other is only when another collider basically hits this particular cheese, I want to do this action, and that other collider is basically your character. You could do that, or you could just give it like you've given it over here. You don't need to give any parameter. Anytime it just encounters something that intrudes its collision space, it will work. So you could do either of these two methods for actually making your game work. So that is basically covered around 4 of the scripts we have. The other one is random map and menu switch. So menu switch is just basically for again, we'll deal with this again when we are doing UI also. When I want to basically start the game scene, I am just using menu switch, that's all. Whenever I want to switch between different menus, for this we have used the control instead of using it in scripting. We have actually added some buttons and used that, which we'll look at in the next session. This is another important one, which is randommap.cs. So what we are doing in this one is basically trying to generate all the maps randomly, and this is basically all the 6 scripts that we have used. So what we'll do here is, there's basically an array of game objects, and the array of game objects contains all your maps, and then I have a float value which is basically 50, and I'll come to the reasoning of why it's 50 later. And then I have a variable, and then I also have a value called sec. So these are some of the values I have. Let's just quickly look at why each one of these even exists. So when update is called, I'll set create equal to false, and then or rather I'm checking if create is false and I'll set it to true, and then I have also given something called start coroutine and then gen scene. So this is what I've given over here. So to simply break this down, what I'm doing is, let's just come to this particular function to understand how this works. So in gen scene, right, I have basically given something called an enumerator. So what I'm trying to do here is basically get a random number from 0 to 4, which I'll use it to address the maps that I have randomly I've created. And then what I'll do is use something called instantiate, which means it will create a duplicate copy of the existing map. So I have an array over here. It will pick the random number is picked over here, and I will choose which scene I want from the random number and refer it over here. And then instantiate what it basically does is, you have to give 2 values to it. First one is basically which map you want, second one is in which position you want it in. So that is why I've used this 50f over here. So the reasoning behind that is because I have kept the width of each of these collections as 50. As you can see, I have it roughly at 50 basically, the size of this. So I want it to be generated after this thing ends particularly. So I have the z value at 50. So I want it to be generated right after 50. The z value alone keeps changing. The other planes are the same, xy planes. Since I only want it to be moving in one direction, I'm just going to keep everything else constant and keep generating maps only in the z direction and keep adding 50 at a time. So what happens over here is, instantiate will pick one scene and place it 50 units ahead of where, or 50 units, or I've used 48 for every subsequent value. So 48 units ahead of where my existing scene map already is. That is how instantiate works. And then I want it to wait for 3 seconds before I do another action. That's why I've used this, because if I don't put this line, it'll start generating a lot of maps, and that is not something we need. We just wanted to like generate maps as far as what your character can see. This will make it very bulky if you don't give this line. And then I'll set create to false. So what I'm doing here is every time create becomes false, I want this to happen, and when it's true, this does not happen. So in the update function, so for every frame we'll keep checking this value. So until this 3 seconds are over, this won't become false. So in that entire time, this won't even be called. This is basically working in a very circular manner, if you get the idea here. When this three, so first it's true, so throughout all these lines it's actually true. So when it's waiting for 3 seconds, the update is still being called, but then the create value would still be true over here. Hence you won't even come here, and this won't happen. Only after the 3 seconds are over, create is set to false, and then obviously when create is false, I'm going to call this again, and this keeps going on and on. Maybe take some time and spend looking at this code. It's not very big, but there's some amount of intuition that you need. If you get that, and then this is a fairly simple idea. So these are some of the codes that we have covered here for intermediate C# scripting. This might be a lot to take in at the first time, but if you can understand the intuition behind each and every line that we have used, it's a fairly simple concept, and that's the reason why we'll be giving you the codes as well. Try looking through it, and it might actually be easy to understand. So as always, let's move on to the time lapse video and hope it's fun. See you in the next session.